Hello, everyone, and welcome to today's installment of the Trenchless Technology webinar series. My name is Mike Kesdy. I'm the managing editor for Trenchless Technology and Trenchless Technology Canada magazines, and I'm pleased to help facilitate today's webinar, Getting Wise on Condition Assessment for Manhole Rehab. We're going to take a quick poll, so please submit your answer and then click the blue Return to Presentation button. I'd like to take this time to remind everyone that any views or opinions presented in this webcast are solely those of the presenters and do not necessarily represent those of Benjamin Media Inc., the publisher of Trenchless Technology, nor does Benjamin Media Inc. endorse any products or methods presented. If you'd like to expand your view, click on the arrows in the lower right of the video box to enter full screen view. Today's discussion is presented by Madewell Products Corporation. From coast to coast, most of our underground infrastructure has been in service for over 50 years. It is failing. Replacing comes at a higher price than to restore and protect via trenchless methods. Manhole structures play a pivotal role in the window of access to our collection system. Each one is unique, and each one suffers from I&I, a root cause of structural decay contributing to excessive bacteria, leading to corrosion. The answer is clear. Prioritize rehab and maintenance tasks based on a condition assessment program that works for your community. We encourage attendees to be interactive and ask questions of our panel before the close of today's webinar. Presenting today are Horatio Franco, the owner and president of H&R Underground and H&R Plumbing in the San Francisco Bay Area. For 20 years, he's been a master plumber, but the business model changed from serving residential customers to city county clientele with manhole rehab, injection grouting, and CCTV services for assessment and restoration of underground structures. John Vogel has 30 years invested in the water and wastewater industry. For the last 12, he has worked for Ross Valley Sewer District in Marin County, California, and today serves as operations supervisor in charge of the Condition Assessment Division. He's passionate about doing things with purpose and was part of the turnaround compliance team at RVSD. Finally, we have Jonathan Steele, the president of Madewell Products Corporation, manufacturers of corrosion barrier coatings and concrete restoration products. With 50 years of experience and a long history with NACE organization, creating standards and serving on the educational committee, it's fair to say that John is a pioneer in the coatings industry. With that, allow me to turn this presentation over to Don Rigby, Director of Marketing and Education at Madewell Products, for a quick poll question.
Michael, thank you very much. Madewell really enjoys spending quality time with quality people, and this is, in the name of education, we'd love to make this as interactive as possible. And one of the ways to do that is by these poll questions. And the very first poll question asks the question simply, what does manhole condition assessment mean to you? If you could take the time to answer that and make as much as brief as possible so we can get on with the content of the show. What does manhole condition assessment mean to you? So the options are assessment identification, condition of the structure, structural corrosion issues, planning and budgeting tool, all the above. I think the masses are pretty obvious here. I think the answer is E, all the above. Thank you for that. There's a couple more of these coming down later on in the presentation. And for now, I'd like to turn this presentation over to John Vogel. Thank you, John.
Well, thank you, Don, for having us, or having me. And I want to give a special thanks to Trenchless Technology and Benjamin Media for hosting, as well as for Madewell for sponsoring this event. We're here today just to give a little bit of information about, I guess, who we are and what we do. It's humbling to be a presenter in a venue like this. So I'm John Vogel. I'm the operations supervisor at Ross Valley Sanitary District. We service a series of communities just north of the San Francisco area, about population of 25,000 people, about 15,000 EDUs. We're in sunny California, though I don't know if the sun's ever going to come this year. It's crazy weather as it is, but nonetheless, I want to talk a little bit about our system. And we have about 194 miles of gravity sewer, about 15,000 EDUs, about 200 miles of private lateral. Now, we're not in charge of the private laterals, but we have enforcement programs that take care of that. Most of our pipe is 6 inches smaller. We still have a series of 4-inch main line. About 73% of what we have is 6-inch. A lot of that's still VCP, but we're steadily moving towards upgrading and upsizing all that to 8-inch. We have about 40% of our pipes are in easements, and our terrain is challenging. We're in a valley. We have steep hills on both sides, and they've built homes right at the side of each mountain. So we have a lot of elevation changes, which makes both design and access quite difficult for the manholes and the pipes. Then we have about 5,200 manholes or raw holes. That's the makeup of our system. Most of it was built plus 50 years ago, with still a large percentage that's still 100 years old or older. We're one of the oldest sanitary districts in California. In fact, not the oldest sanitary district. I believe we were established in 1899, something like that. Our story is, when I came to the district, is we had quite a few challenges. For the longest time, the infrastructure was neglected. They weren't doing a lot other than fixing things as they came. It wasn't by design, but they were certainly running a run-to-fail model. This is adopted for most of our existence. As things would break, you'd respond. We had crews going out doing night calls on a regular basis. We had both problems in the pipes, the manholes, the pump stations, the lift stations. Just about everything was falling apart at one point or another. We have the badge of having some of the most overflows in Marin County, and probably in the North Bay area. Our count of overflows is up. Our volume of overflows is up. We suffer from incredibly high I&I levels. Our factor on a normal storm is a factor of 10. On the 100-year storms, we're factors of closer to 15 and even 20 in some of our basins. We're getting a lot of I&I coming into the system. We had some plans, through management plans or design plans, but much was not being followed. None of our information was digital. It was all on paper. All of our maps were in books, and we would take stickers and stick them from one place to another, depending on what kind of work we were trying to do in terms of any type of O&M management or any type of work order tickets. Is all done by hand. And then, of course, that would go to folders and papers and whatnot. And then, of course, a lot of the times we didn't even really know what we had. We had a lot of systems that were in the wrong place on the maps. We had systems that weren't mapped at all. We had any kind of capital work that had been done over the last 2 decades wasn't being updated in these paper map systems, so any changes weren't being tracked. So just even getting a crew to go out and accomplish work was extremely challenging, because we had a rough idea where things were at. Nobody knew anything about where any kind of defects were at. And when we would go do repair, it was based on gut. So someone would say, I think we need to go fix this pipe because we've had a few SSOs in this pipe. This, of course, resulted in bigger problems. This is one of the big storms. This is our downtown San Anselmo area. And that's roughly in the middle of the road, 2 or 3 feet of sewer pumping out of the system, just flooding the entire town. This was a turning point in the district. We had a lot of attention. We made, I believe, national news for this, let alone regional news. And we started to get a lot of attention on what the agency was doing, or in this case, not doing. This event was in 2010. I came in 2011 as a pack of workers that were brought in to help shore up not just technology, but to help develop how we were going to go about exploring and finding out where these problems were. And as the year continued, we wound up with quite a few more SSOs. or spills nowadays, we call them in California. Some are small, some are big, of various different sizes, and we had a lot of them. So what we started to do, and the first step of any good program, is you have to know what you have. You have to know where it's at, where it lives, and what the condition is. And that's the big focus of today is our condition assessment program. We started from scratch. We started televising the system. We started televising the manholes. We started recording information. We captured all that data, and we pushed that all out through the NASCO system. We'll have some slides in that later for that. But we use a coded standard so that way we have an ability to measure one pipe from another for year over year and get the same expected results. And that helps drive our capital planning. But as we started to go out and look at the system, we started realizing the severity of the issues that we were running into. We have about 5,200 pipes in the district and about 5,800 manholes. And what we started, about a third of those had some grade 5 level defect or another in those pipes. And they weren't just breaks like we saw in the top left-hand corner here. We had big gaps in our pipes. We had sections of pipes that were missing. We had connections that were broken. We struggled quite a bit with blockages and infrastructure. There was also at the same time going on, there's a big push by PG&E, which is our power company out here, to do cross-bore work, and they were boring water mains as well as gas lines through our system on a regular basis. The bottom left one was an electric, big 10 kV power that was driven through our stuff. Not only did we not know where our assets were, they did not know where our assets were, so they were just out performing work, and they ran into us. So we had several of these occasions. Lots of maintenance problems, lots of roots, lots of degradation of the system. We had collapses in the system. We had concrete peeling off the walls that was no longer adhering to the rebar anymore. And ultimately, what came of this is my slide didn't advance, excuse me. 2013, we were visited by the Water Board, which is a state regulatory agency in the state of California. And they came and gave us a cease and desist order, which basically says it's time for you to start taking care of your system. Otherwise, the state would get involved and start managing the system for the agency. This is not a good look for any agency anywhere in the country. But what this did is it forced the agency's hand. Now, the agency, in terms of my perspective, we were doing everything we could with the resources that we had. What we lacked was more resources to go out and take care of problems. We lacked capital funding. We lacked infrastructure funding. We lacked just maintenance and upgrade funding. They had us running on a shoestring, and the board of directors just simply refused to raise rates and address the problem because they wanted this region to be as affordable as it possibly could. Now, I agree with affordability, but the nearsightedness of this led to an agency that was just, it was unmanageable. It was unwieldy. We had way too many overflows, way too many problems with our system. And so they came and addressed that problem, and this forced the agency to start dealing with funding. It helped us really establish our asset management plan, or a system that we still use today. That starts with good inventory, and asset inventory is number one. You have to know what you have, where it's at, and then what the condition is. From that, we can define, what the levels of priorities are. We do that through an evaluation process. We use risk asset management. We use risk models. We have models for the pipes. We have models for the manholes. We have models for our vertical assets like our pump stations, and we have everything put together in a manner where it becomes defendable. And so when we develop a plan for rehabilitation replacement program, this also affects our regular day-to-day maintenance activities. We want to be able to defend our actions and our activities so that when something else fails, we can refer back to our plan and say, yep, we understand we missed one, but we had 3 other systems ahead of that were in much worse shape. And this is the heart of good asset management, is being able to understand where you're at and what you're trying to accomplish. And you have to present that in a way that ratepayers understand it, as well as the stakeholders and everybody involved. In this case, the water board is our biggest stakeholder that's involved. And then that comes back to implementation. Once we had the plan, we started to implement and we started to push capital out. The first year after the cease and desist order came, once we got our plan together, we invested about $12 million into the system on the worst of the worst. And since that time, we've been a little over $15 million a year, and to where we're about $100 million invested into our system now. And that has made a huge difference. And that has been financially fiscal. We didn't obviously have that money. We had to raise rates. We bonded, and all that is done through, good asset management and good program management in order to get us to this point. We have quite a few lift stations that were bad, quite a few manholes that were bad. We had everything from brick falling out. We had just full delamination of the concrete. We had rot, and so we started inspecting our manholes as well. I think we just about have them all inspected now. We have 4,800 manholes. We have about 4,400 inspections in the system. Some of the ones that aren't inspected are those real hard to get ones. We actually have some manholes that are under buildings or inside of buildings that you have to open the hatch door in someone's kitchen in order to get to. No joke. Those still exist in our system. But as we look at the corrosion, we looked at what was going on in our system, we started looking for methods and technologies to deal with this, because even though $100 million is a lot of money, it's not enough to do everything. We would need billions of dollars to replace everything that we have in our system. So we start looking for technology that gives us the biggest bang for the buck in our infrastructure rehabilitation. And one of the systems that we found that works really, really well for us in terms of increasing the life of existing lift stations and manholes is we coat them. We go in and we have those sprayed, and we have the cementatious applied. We chose to go with an epoxy on top of it, which is why we like the Madewell product. We found that it outlasts everything that we do. We've done it all. We've done the insert liners. We've done the just cementatious by itself, and we find that the epoxy line stuff outlasts it by far. There's about 150 manholes we're looking at now that have already been coated once with just cementatious, and we find that they're already starting to wear out again. This is in our low-lying areas that suffer from a lot of H2S damage, and we're going to have to go in and clean them up and reline them again, but this time we'll come back with the cementatious on top, or excuse me, the epoxy on top, and we'll get the same life. So we've got some assets that Horatio did for us years ago, and other than the staining on the walls, they look just as good today as they did the day we put them in. We see no evidence of that asset becoming an issue for us, and that's our goal. When we look at any rehabilitation technology, whether we're doing outright replacement or whether we're doing just rehabbing the asset, we want to make sure that it's the best bang for the buck, and it's the right decision for the ratepayers. Because ultimately, we're responsible to our ratepayers. We don't play with our own money. We play with someone else's money. We talk a lot here about stewardship, which is the idea of taking care of somebody's stuff better than you take care of your own. And that's really is our mantra. We want to make sure that the decisions that we're making will outlast ourselves, so that when we leave it to the next generation, that they not only know what they have, but they have something that's maintainable. And we look at that investment on everything that we do. And we make sure that as we're investing ratepayer funds, that we give them that level of service that they expect. And, we're all in the sewer business. We all understand what they expect. 24 hours a day, 365 days a year, when they flush the toilet, that is going to go away. When they take a shower, that water's going to go away, and it's going to be dealt with by us. And that's our goal, without any interruption, without any issues. Obviously, we're not perfect, and we still run into problems. But we'll talk more about where we're at today versus where we were at then. But now I'm going to take a break, and I'm going to turn this over to my good friend Horatio, who's going to talk a little bit about some of his experiences with working on some of our.
Thank you, John. My name is Horacio Franco. I'd like to thank Trenchless Technologies for hosting this. John Steele, owner of Maywell, so once again, I'm the owner, president of H&R Plumbing. I'm proud of the people that I work with and the accomplishment. We're not perfect, but we're getting there. As of today, we're a company about 15 employees. We run strong, and we've been able to keep our same crew for between 5 and 12 years, probably the oldest one. This picture was taken back in 2014. We're a magazine, I&I magazine, that took this picture for us. When we decided that we wanted to do other than just regular plumbing, residential plumbing, we started looking into an asset, and I got interested in doing manhole rehab. So I did some research and visited company A, company B. And see, we decided to go with company M, Maywell. When we one of the things that really got me attention from Manhole, that was a company that was making all the products themselves, and they keep everything in house. And we started 17 years ago, and it's something that we're still doing, and relation that we still build and working stronger than ever. We got let me go back to this picture. We got a trailer like this, trailer that has all the equipment that we need to apply the products. As I mentioned, we got it about 17 years ago. It's a trailer that we still use today, and it still looks good and still works as it should be. Mainstay composite liner enable us to deliver value. I'm a hands-on contractor for 17 years. I know my people. I know Maywell products and equipment. I know the problems, and I know how to solve them. H&R composite bits projects, and when we get them, we always get a call back to do more work on most of the cities. When we get to a manhole, we find a manhole. Every time that I open a manhole, every manhole is different. We got manholes from bricks, precast manholes. I have seen manholes that half of the manhole is precast, the other half is steel. I've seen manholes that it was made of some type of liner, and I've seen manholes that they were nothing left, just soil in there. And I haven't seen a manhole that we haven't been able to rehab. The issues that we come across every time that we trying to rehab a manhole, it could be multiple issues. We find roots inside the manhole. We have infiltration. We have a manhole that has been previously coating, and now the coating is failing. We find the runs. We have the runs that we are taking off from every single manhole that we rehab. Some of the issues that we deal with prior to start rehabbing a manhole. We have a manhole that it is leaking. Before we start any rehab, any prep, the prep requires about stopping any infiltration. We stop infiltrations by a few meters. All depends on if we have a manhole, a gusher, or a dripper. We can either stop the infiltration. We use fast-setting hydraulic cement, or we can use grouting. to stop the infiltration. So once the infiltration is 100% stopped, then we can proceed to the rehab. We have issues where the deterioration goes beyond showing the aggregates all the way to the wire or rebar. The way we approach this is we prime the metal. It could be a rebar or it could be the wires. So we prime it to prevent more deterioration prior to applying to rehabilitate the manhole. Once we restore the manhole, I like to say that every manhole looks the same once it's rehabbed. On the left-hand side, we have a manhole that is being rehabbed. We got the microsilica cement top coated with epoxy. We like that every manhole looks the same once we're done, that we have no infiltration, no roots, and we cut the steps. On the right-hand side, we have a wet well. The same way, we like to have every single well to look the same. We quarter from the floor all the way to the ceiling, every single corner. On this one, the way we prevent any overspraying, it would be taping off the pipes or any wires that might be there. And this time, I like to stop and have one of the mentors and one of the gentlemen that has shown me more about manhole coating than anybody else, and that will be John Steele, owner of Maywell.
Hello, everybody. The picture you see here is obviously of a brick manhole with steps in it, and as many of the manholes that exist in Ross Valley are under this same condition, they experience a high level of microbial influenced corrosion, and that causes the mortar between the bricks to deteriorate, causes them to get loose, to leak, in some cases fall out, and this allows inflow and infiltration, which John Vogel said earlier caused nightmares for Ross Valley back in the day. They're starting to get this under control now. That's a good thing. Now I'm going to describe a little bit about what Horacio was just discussing regarding a composite liner and what exactly that means. Basically, a composite liner, by our definition, is one that consists of a restoration layer, and usually it's a cementitious material, followed by an epoxy top coat. And these are done consecutively, one right after the other. We don't wait in between. Now, what you see before you here is a picture from the 1960s. U.S. Steel invented a process in the early 60s using epoxy, which had only really become commercially available within the 10 years or so before this. And what they would do, this is in a concrete pipe manufacturer's plant. And on the top, what they're doing is they're making concrete pipe, and then the two men to the left are moving this freshly manufactured piece of concrete pipe, and then they're bringing it over to what they call a mainstay machine. And then we would spray a 125 mil layer of coal tar epoxy at that time on the inside of the concrete pipe, and then they take the pipe away from our machine and they take it into a steam kiln and cure it overnight, and the next day it was hard as a rock. And there were some 50 million square feet of this done back in the 60s and 70s, but the concrete pipe industry sort of lost its way, and other materials became more popular. But my father purchased Mainstay from U.S. Steel back in the late 60s, and we have since today converted it into a system that we use for restoring manholes, lift stations, wet wells, and that sort of thing. Now, epoxies have been around a long time, and I think most people would accept the fact that they can be formulated to be resistant to a sewer environment. There have been some coatings used in sewer environments that are not necessarily resistant to the environment, but I don't think we need to worry about the first bullet point much. The second two bullet points are what we are most concerned with. In order for barriers to work properly, they have to be continuous. And that means that they have to be uniform in thickness, and they have to be free from any holes or what painters call holidays. And they also need to be tightly bonded. Now, anybody who's been in the coating business for a while has a few of these pictures laying around. And I think the expression on the guy's face and back kind of sums it up, that when we have peeling paint, it's not good. And the inside of a manhole and lift station is a pretty inhospitable environment for applying coatings. Some people in our industry apply epoxy coatings and other coatings directly to the substrate without any sort of surface underlayment, and that's just not the way we do it. And I'll explain why our system works well in the next couple of slides. Here you see a worker in the bottom left-hand corner. He's pneumatically applying microsilica restoration mortar. And this particular microsilica restoration mortar goes on anywhere from a ½ inch up to 2 or 3 inches thick, very low shrinkage, has a compressive strength of about 10,000 psi at 28 days. And it's just easy to mix and pump and spray. The structure on the right has actually been cement mortar lined using a centrifugal machine, and in this case the mortar is pumped to the centrifugal applicator and spun onto the surface. And if you look at the surface there, it's fairly smooth, but it has a dimpled surface that is really not suitable yet for the application of epoxy coating. Here you see a worker who's entered the manhole, and he's got a sponge in his hand. When you centrifugally apply the mortar, typically that's all you have to do is just sponge it. If you apply it with a nozzle, typically you would knock it down with a trowel first and then sponge it. And after this step, you have a very unique situation. Now, this is not in a manhole. This is taken, it's hard to get good pictures of a finished mortar system in a manhole. But this is the system, this is the sort of finish that you're looking at when the mortar is complete. Now, if the manhole wasn't wet before you put the mortar on it, and they almost always are, you would wet the manhole first, and I'm going to talk about surface preparation here in a minute. But then after the mortar is applied and it's finished, you have a condition like you see in this picture where you have a pristine, smooth surface that is ideally suited for the application of an epoxy top coat if you do it right away. And that's what they're doing in this next slide. They've just finished the mortar in this manhole just maybe 20 or 30 minutes before this picture's taken. They enter into the manhole and they spray a 100% solids epoxy product. 100% solids means it doesn't contain any solvents, and it has essentially zero shrinkage, so wet film thickness equals dry film thickness. And they're going to spray this corrosion barrier in the inside of this manhole with 125 mils. We do spray it thicker than that in some cases, but if you have the restoration mortar underlayment, there's really not any need to go much above 125 mils. And when you're done with all of that, you end up with a surface that looks like this. Now, there may be some inspection that you would do after this point, for example, holiday testing and adhesion testing, which I'm going to talk about here in just a minute. But this provides a smooth, continuous, holiday-free, corrosion-resistant lining that should last for decades. And forgive me here, but I'm not exactly sure who we're going to next. Is it back to the editor or Don?
It goes back to the editor.
Okay.
Thanks, John. And this is Mike again. I just want to take a brief moment here and interject, because we've heard a lot of great things thus far. So let's recap what our experts have covered the first half of this webinar. Sewer districts like Ross Valley in California, they have the ability to get proactive with maintenance and rehab work through condition assessment programs suitable for the community. Beyond brick or concrete construction, every manhole is unique, and these complex structures deserve periodic inspection and restoration to protect against structural decay and corrosion. And then from John, we learned an effective barrier to corrosion like epoxy must be resistant to the sewer environment, continuous and uniform thickness, and tightly bonded to the surface. Now I'll turn it back over to Don with another poll question. Take it away, Don.
Thank you, Michael. I do like these poll questions, and this is how we can be interactive. There's a lot more interactivity forthcoming. So here's the question. Which do you prefer, level 1 or level 2 inspection, according to NASCO? Now, when I say that, I just lost my place. I'm going to find it again. The answers are, where does it? Nothing beats manhole entry. That's level 2 for best results. We avoid man entry, good, with high-def cameras to capture defects. We do both based on need and visible clues. And then the last option is historically level 1, top view only, serves us well. Based on the replies coming in thus far, I'll say item C is probably the most popular and most dominant. We do both based on need and visible clues. I think that's pretty safe. I thank you for that. There's another poll question forthcoming. And by the way, if there's questions that come to mind during a presentation, I encourage you to go ahead and submit that question online, and we'll get to it at the end. I trust we'll have enough time to get through it, but we may not. We'll do the best we can. My interest now is to go back and reintroduce John Vogel, Operations Manager at Ross Valley Sanitary District. Thank you, John.
Well, thank you, Don. I think what we'll do now is familiarize everybody a little bit how we got to where we are at today. And it started back in 2010. We purchased an Aries Pathfinder TV van. Very simple in its operations, but very effective in what it gave us. It came with a push camera, and it came with a TV van suitable for televising pipes, and we started that process. For manholes at this point, we were still using just a surface visual look down. We would take some pictures. That was a little bit limiting, although it was very fast. We get a lot done. It wasn't long after we started televising with the Pathfinder system that we realized that we needed a little bit more for the manholes. That we weren't quite getting an inspection down inside so that we could see what was going underneath the rim, or some of our manholes are quite deep and we're having trouble seeing down there. So we invested in a pole camera. These are quite common in the industry. There's several models out there. This happens to be the one that we chose. We found that they were very detailed. We could actually get the camera down to the base of the manhole. We could look inside the inverts. We could look at the annular space if we were doing lining. We could look at what was going on with the structure of the manhole around the stairs or around the steps. But what we found is it's slow. It takes a long time to fully visually inspect an entire manhole, and guys were missing big sections of it. You know, they would get about half of the manhole, it seemed like, and it seemed like that one place that we always wanted to see in the manhole when we were trying to determine rehabilitation or determine the severity of the I&I. I&I was a big driver for us, so we really did a lot of this work during the wet season, so we had water coming in. But the camera had a hard time, you know, focusing in on a big enough of an area that we could see what was going on. And then we had a funny result. When you start looking at these pole cameras that are spinning circles inside of a manhole, especially if you're in the office, it makes you seasick. And it gets really hard to evaluate and really hard to look at that video because you're watching a big screen in front of you and it's just spinning circles around as you're trying to look inside this manhole to see what's going on. And you'll literally get seasick and you'd have to stop what you're doing for a while and go do something else. And I know I'm not the only one to experience this, but we definitely had it here. So we moved and we adopted, we went back to surface inspections, but this time we added a little more technology to it. We were using iPhones to capture our video, and we tied that to a GIS system using an application called GIS Field. And what that allowed us to do is to go out into the field with a work order and capture some video. And then that gave the operators the opportunity to enter their defect codes right out there in the field. So this way we weren't bringing information, we weren't bringing uncompleted work back into the office for someone else to do. We'd let the operators do their job. They went ahead and assessed the manholes and everything they could see, and they could zoom their cameras, and they can control the lighting. This is a lot better these last few years than the cameras of the old when we first started doing this. So we did this with about 1,200-ish manholes as we started to inspect, and this gave us a good swath of what the state of the district was in terms of, and they were all surface inspections. Now, they're very fast. You can move through the system very quickly. You can gather information. But what we lacked again, and we saw from the first time we were doing the still photos, is you just lack detail. You can't see under the rim very well. A lot of our manholes are not concentric. They're eccentric, and anything off under the shadow of light is really hard to see. It's hard to see the cracks, the breaks, even to the point where they're deep enough, you can't see the base, which a lot of our manholes still have brick bases. And we weren't able to see where we were missing bricks, or where the mortar was starting to come out, or the concrete was starting to degrade in these manholes as we started to look. So then, I would say 2 years ago, we invested into an iBox system. We purchased a system that could accomplish both CCTV as well as Panorama and Panorama SI, which is 3D imaging technology for both the pipes and the manholes. We also invested in a 3D measurement tool that allows us to measure the manholes as well as to measure the pipes for both diameter as well as length and height, as also its curvilinear position in the ground. We incorporate that now with our GIS. We take GPS sticks out in the field and we capture where those locations at. That just helps drive better information to our now digital maps. So the days of paper for us are all gone, and the days of paperwork orders are all gone. All that's driven out digitally through our CMMS system. We take this information now, and what's unique about the Pano, it's fast. We can inspect most manholes, not counting the setup time, in about 5 minutes. So the equipment goes down, it performs a scan. You pull the machine out. We do it both ways. I have the operator code the information in the field, and/or we accumulate a bunch of work and we bring it back to the office and code it in the office. And we do that based on traffic control scenarios. And what this equipment allows us to do is to go out into the field, get a lot of information very quickly, very fast. It's very detailed. We can control the full inspection. We can see the entire manhole from inside the office and make better decisions on what kind of rehabilitation efforts that we're addressing, whether it be I&I or just structural degradation, and it's safe. One of the key components that we look at is making sure that the tasks that we're asking our operators to do are as safe as they can be. This gives us a full level 2 inspection because we get top to bottom, but a person never breaks the plane. It's all equipment based, it's all machine based, and so the machine goes down, does all the hazardous work for us. The operators are just standing at the top of the manhole and just deploying equipment, and it's great for them, it's great for the equipment. It's so much more detailed and so much better results than what we were able to do in the past. Now today, there's new equipment available where you can actually accomplish this with the 3D GoPro cameras. There's a couple manufacturers now that are making. They're even lighter, cheaper, quicker, and even faster than before. We're starting to wrestle with the idea of sending our data out and having a service perform an AI code to it. And it all comes back, whether we do it by person or whether we do it by machine, it all comes back fully coded and fully assessed. We do everything through the NASCO standards, so it's all level 2 inspected. And we're even going back to some of our old stuff and reapplying that standard to it, so that way we can get that consistent result year over year. So this way we don't get one manhole that needs to be fixed on some older standard or some made up version that someone's come up with. But he gets neglected, and we wind up having a problem in that manhole where we have a brick fallout. One of our big issues with like our brick bases is we'll lose a brick, and then we don't know that it's lost. The manhole's still there, but the brick finds its way down into the system. Again, our system's a lot of 6-inch stuff. We wind up with a blockage because the brick gets hung up sideways in a pipe on a joint, and it's just not a good look for us. So one of our focuses today is to get out there and find all of our systems that have missing mortar or missing brick or loose brick, and to get those queued up for doing our next batch of rehabilitation. And every year now we put a percentage of our capital budget to fixing these manholes, which addresses two issues. We take care of the structural side that's failing, as well as we take care of the I&I that's coming in. And I'm proud to say that, we do everything NASCO. The PCP system, it's just a great system across the board. We dump everything in our CMMS. I maybe talked over my slides a little bit, guys. Everything is digitized in terms of what we're bringing into the information. It's all applied to risk models now. We deal with risk reduction is how our model works, and we like to deal with the highest risk stuff first, and we work ourselves to the lowest risk so we have a manageable system. Of course, we're using Madewell products. We love the product. We are big fans of prep. We will prep our manholes down to get them prepped and set to go. We'll also, if the manhole's a little bit on the edge, we'll do a scratch test. We'll do a penetration test. We want to make sure that the manhole's just not too far gone. Let's just face it. We all know that sometimes you get into an asset and you just can't rehabilitate it. So we do that test to make sure that it's a good candidate for rehabilitation, and then from there we rehabilitate. We've pumped all kinds of money into our capital system, but we've done it intelligently. We don't do anything by gut anymore. We have our in-house point repair program. We have capital programs, and we are dealing with issues as we get through the system. We no longer leave things for the next generation. We are fixing them today, and we're making our system better. I'm proud to say that last year, California saw record rains in our region. I mean, record, like they never predicted how much water we would see. And we had not one capacity SSO during that period of time. And that is saying something. Back in the past, that would have been a catastrophe. But because of the efforts that we're putting into our system, because of the I&I that we're addressing, and the structural issues that we're addressing, our system is performing the way it's supposed to. Doesn't mean we don't get nervous and don't come close, but we are so much better in control today because of condition assessment and our active rehabilitation. And I'm even more proud to say that last year, or 2022 year, we won the California Collection System of the Year in the state of California. This is a big award for our size of agency, and we are so proud that we were able to achieve the standard that our association measures against. And it's a peer review. So we had peers from other agencies come out and evaluate us and look at all of our information, all the things that we've been doing. And that is how you get to where you're supposed to be. So we're super proud of that. Super excited for what is coming in the future. And we're going to continue driving forward to leave our system better than it was when we found it. So I want to go ahead. I'll turn this over to Horatio.
Thank you, John. So now I'd like to talk about a little bit about a project that we did, in fact, for Rose Valley Santa District. That was back in 2020. I got a phone call saying that they wanted to look at some wet wells that they have issues with. We look at around 15, and out of the 15, 1,208, they were really deteriorated. As you can see, the upper left-hand corner, there was a deterioration. Then on the upper right-hand corner, after we prep with hydroblast and we got to the aggregates, some of them we lost about 2 inches in the process of prepping. So we have to add up at least 2 inches. The bottom left corner, after we apply the microselect cement, the bottom right, we apply the epoxy on it. So this wet wells, lift station, Rose Valley, we did 8. There was a project that was kind of a little bit unique for us and interesting. we had to run the bypass. We have to supervise the bypass 24/7, making sure that there was no overflows. There was making sure that the pump had enough fuel. The pump was working properly. We completed this project with 8 technicians. We completed in 12 days. So by the time we were done, we did a holiday test on every single one to make sure that we had no pinholes. There was no defects on the coating. By the time we were done, we found no defects. The coating came good. The project came on time and came on a budget. So there was a project that I was kind of proud of the crew that spent the time on every single lift station. Part of in our company, some of the things that we emphasize a lot is safety and training. We run our traffic control, confined space entry. We train the guys. Every single crew has been trained on confined space entry, how to use every single piece of equipment on the confined space. Goes from the blower to blow air, to ventilate the manhole, to use the tripod, to use the gas monitors. Every single technician has a high visibility uniforms. We're on the road all day long, so we want to be have a high visibility on the road. We are located in northern California and San Francisco area. We cover the whole state of California. Some of the major cities that we've been working is Berkeley, Napa, Santa Fe District, San Jose, Sacramento, Oakland, and Richmond. Of course, Rose Valley. So we, with a crew, one crew, we covered the whole state. So we travel anywhere that there's a project that needs to be done. We travel. Today, the crew is working in a city close to Fresno. It's about 4 hours away from us driving. So the crew's down there. He's staying down there. And with this, I'd like to thank all of you for being here, for attending, and we'll pass on to John Steele.
Okay. Well, folks, Horacio had a slide that said velocity equals corrosion. As far as microbiologically influenced corrosion is concerned, age also affects the corrosivity of sewage. So this isn't a manhole. This is actually an intake structure in a sewage treatment plant here in the Atlanta area. So as sewage leaves from residential areas to lift stations into collection systems, back and further down the line, it becomes more and more corrosive. And especially in a place like Ross Valley that has lots of changes in elevation, you have a lot of turbulence. You just have a lot of problems with corrosion. If you look at this brick manhole, this picture was actually provided to me by John Vogel. So this is apparently a manhole out in his collection system. As you can see, that's in pretty bad shape. As we talked about earlier, our process is to apply a cementitious underlayment first and then an epoxy coating. And the reason why is because this structure is so rough and uneven that it would be almost impossible to apply, or very difficult to apply, an epoxy coating by itself and get it continuous and holiday free. So I'm just going to touch on a couple of the things we do. We train our certified applicators in the use of our equipment, but we also train them in the issues like surface preparation, adhesion testing, holiday testing, film thickness control, all those various things. But starting with the very first one, surface preparation is key. SSPC and NACE have now combined, but they had a joint standard that was SSPC 13 NACE 6, which called for various methods of preparing surfaces, one of them is what was called high pressure water cleaning, and that's defined by the standards as being between 5,000 to 10,000 psi. Our contractors typically do this at the lower end of that scale, about 5,000 psi. And the picture on the top you see there is a 0 degree tip that's rotating, and at 5,000 psi it's pretty strong. The picture below that is ultra high pressure water blasting, and those pressures above 10,000 psi are just not really suitable for use inside a manhole. Now the idea being that when you're done with this, you're going to have a surface that has no dirt, has no loose material on it, and it should be down to a sound substrate. And if it's not, we're going to have to keep cleaning until we get there. I'm sorry, guys, my computer just went off on me.
I'm sorry, John, what did you just say?
Well, my computer just crapped out on me.
I can advance the slides for you. Go ahead.
Yeah, there, okay. The International Concrete Repair Institute has a method for identifying concrete surface profiles, and you can see there's acid etching, grinding, and so forth. Most of the surface profile that we would end up would be a CSP 6 or greater, and that is one of the things, for example, that we teach our installers. We also teach our installers about adhesion testing. There's many different ways to perform adhesion testing. And in fact, at the end of this program, you're going to see that we have a technical bulletin that we've issued on the subject. There's a lot of different standards to be considered. But if you look at this particular picture on the top there, that's an actual picture out of ASTM 7234. And when we're done installing our epoxy and our mortar, it should be bonded to the concrete or brick substrate with a tightly enough that if we pull off a dolly like you see in the illustration at the top, it should actually pull the epoxy, the mortar, and probably some or quite a bit of the underlying substrate. And so if you were one of our applicators and you came to one of our classes, we would teach you all about these standards. We teach you all about how adhesion testing is performed. It's a force versus area relationship. There's lots of different types of equipment that can be used to test. They're not the results from one test doesn't necessarily correspond with the results from another. So we teach our applicators about how that's done. Again, we also teach them how to control film thicknesses for both mortar and coating, and then we also teach them how to holiday test those linings to make sure that they're holiday free. And with that, I guess I'll turn it over to Michael.
Hey, Michael, let me make an executive decision here real quick. Michael, may I?
Sure.
I think we have some pretty passionate presenters, and I think we've probably exceeded our time limit here. It's getting close to 3 o'clock Eastern time right now. So I'd like to make an executive decision here to suggest that we minimize the poll questions and we actually minimize the live Q&A. And my promise to you is that we will answer every question that came across the transom in writing. And when you have a document that talks about each question from an owner perspective, from a contractor perspective, and from a technology point of view, that's a pretty comprehensive FAQ document. That's what you could expect. Now, give us a couple weeks to do that, and I think you'll be pleased with what you receive. But what you'll receive in 24 hours from now is a couple promise documents, and we'll get down to that right here. A couple promise documents centered around adhesion and centered around the application composite liner. So before we sign off, I'd like for John, Jonathan, and Horatio to spend a moment, 10 seconds, your parting wisdom for the participants on this webinar. Please go ahead, John.
Well, I'm looking at a question here that asks a good question. Does the cementitious coating cure okay with the epoxy sprayed over it? And the answer is yes. cementitious materials like to be kept moist during their cure process. So the epoxy coating does a good job of helping the mortar cure.
Is
Ross,
that your parting wisdom, John?
that's it.
Okay, John Vogel.
I just 10 seconds. Get out there and assess your stuff, guys. Get a handle on what you've got, put it in a logical manner, and present it in a defendable approach so you can get the funding that you need to go out and fix things. I think that's the order of business that at least our board requires. I'm sure that your boards and stakeholders are the same way. So get out there and assess it, guys. You got this.
Horatio, 10 seconds. Thank you. First of all, I'd like to thank everybody that attended this webinar, and I'd like to thank all of you that organized this. So it was a pleasure to be here, and feel free to shoot me any questions or anything. Thank you.
Guys, we love doing these webinars, spending quality time with quality people, and there will be a next time. For now, I want to try and respect the idea that we only asked for 60 minutes. I'm now taking 62. I apologize, 63. And I'll let our friends at Trenchless Technology close out the session. Michael, go ahead.
Thank you, Don. On behalf of the entire team at Trenchless Technology, I'd like to thank all of our attendees for joining us today. I'd like to thank John, Horatio for their insight, and Don for lending a hand with the webinar. I'd also like to thank Madewell Products Corporation for sponsoring this webinar. If you'd like to refer to this webinar, you can do so at any time by visiting trenchlesstechnology.com/webinars and selecting today's webinar from the on-demand webinars section. It will be available there for the next year. We encourage all of our attendees to take our exit survey that appears on your screen at the close of today's webinar. The survey will help us improve our offerings as well as content for future Trenchless Technology webinars. The survey will only take a few minutes, and your participation will be greatly appreciated. As a reminder, any views or opinions presented in this webinar are solely those of the presenters and do not necessarily represent those of Benjamin Media, Inc., nor does Benjamin Media, Inc. endorse any products or methods presented. Thank you all again, and have a great day, everyone. Cheers.